All right, we are starting our last unit, Unit 6, and this one is all about stoichiometry. So that's how you say this word, stoichiometry. This lesson here, we're going to define and explain what that is. You'll know that you are on your way towards understanding stoichiometry if by the end of this lesson you can describe the proportions present in either a compound or a chemical reaction formula. So, the first thing I want you to think about is something you've got familiarity with. If you've never baked a cake, you've at least eaten cake. And you probably have a general idea of some of the things you need when making a cake. Alright, you might need, 2 cups of flour and 1 cup sugar, maybe an egg, some oil, maybe a teaspoon of baking powder or something like that. All right, so you have this recipe that tells you how many and how much of each ingredient to make a cake. All right, now this recipe you can easily be like, what if I wanted to make 5 cakes? What would I do with all of these ingredients? All right, if I wanted to make 5 cakes, I'd just multiply all of them by 5. All right, stoichiometry is just like interpreting a recipe for a cake. All right, it's just instead of your recipe being different food ingredients, your recipe is going to be chemicals. All right, so and the numbers, the amounts that you need, that's going to come from your balanced reaction. All right, so do a little quick balancing practice here. We've got Mg and O, Mg and O. We've got 1, 2, 1 and 1. Oop. 1. All right, so I need to double my oxygens on the product side. So I'm going to put a 2 out there, which fixes oxygens, but that also applies to my magnesiums. All right, so I also need to put a 2 out here. All right, so you can read this recipe as you need 2 magnesiums plus 1 oxygen to make 2 magnesium oxides. All right, so that's stoichiometry, is just kind of reading your reaction and using it to predict how many products you have, determine how much reactants you need in order to make a certain amount of products. All right, if I want to make 10 moles of magnesium oxide, all right, 2 times 5 gives me 10, so I'm going to need 5 times my reactants in order to make that happen. All right, just simple proportions here. So, getting further into proportions, something you want to be familiar with is the law of multiple proportions. All right, definitely something to take notes on. But John Dalton said, elements combine in whole number ratios to form compounds, meaning that an entire atom of one element combines with an entire atom of another element when a compound is formed. All right? And we've seen that before, when we write out formulas like H2O. All right, we have 2 hydrogens to 1 oxygen. Carbon dioxide, 1 carbon to 2 oxygens. All right? This also extends further into a balanced reaction. All right? When we write out those balanced reactions, we always write it with the subscripts as full whole numbers as well. All right? That allows us to talk about proportions of how much we're going to need of things. So, just some practice with law of multiple proportions is either given a picture of the chemical, or really you can get all of this just from the formulas. You should be able to describe what the proportion of each atom is present in the chemical. All right, so for potassium chloride, you can see it's KCl. There's no numbers following those. So it's 1 potassium to 1 chlorine. All right, so when in chemistry, when we don't write numbers, it's because there's only one of them. If there's more than one, we have to put the number in. All right, so looking at the next one, what do you think the ratio of hydrogen to phosphorus to oxygen is? If this seems really easy, that's because it should be. All you gotta do is read your numbers. You got a 3, a missing number, so that means 1, and a 4. So it's 3 to 1 to 4. All right. So that information is going to come in handy as we get into doing more advanced stoichiometry. Another thing you gotta be good at is reading the proportions of a chemical reaction. All right. So, because that's really what we're going to use in stoichiometry, is these balanced reactions and being able to discuss the ratio of your reactants to your products. All right? Could ask this in a few different ways. You could just ask for a ratio of reactants to products. All right? So for that, you're going to talk about that you have 1 nitrogen and 3 hydrogens, so there's 4 reactants to 2 products, which, if you at all remember ratios from math class and things like that, this can be simplified to 2 to 1. All right. You also might be asked about the ratio of each of the separate elements. So just make sure you read your questions carefully. So like say it asks you the ratio of just the molecules in your reaction, that would be 1 to 3 to 2. All right, but if it asks reactants to products, this is one that I know you are going to see on your quiz. You combine your reactants and combine whatever products you have to come up with that number. So some practice with this. All right, the ratio of carbon to hydrogen to oxygen. All right, we've got 6 to 12 to 6. And even better, if you can simplify this, it's going to be 1 to 2 to 1. Then the reactant molecules, so this is just a plain old reactant to product. So count up how many reactant molecules you have. There's no number here, which means that's a 1. We got a 5, we got a 3, and we got a 4. So 1 plus 5 is 6, and 3 plus 4 is 7, and that can't be reduced any. So hopefully these proportions are pretty easy for you to understand, and you have just kind of a general idea of what stoichiometry is. It's the whole baking a cake. Based on that recipe, if you need to make 12 cakes, how much do you got to put in? If you have to make 20 cakes, how much do you have to put in? Okay?